Hi everyone, these notes are on solving quadratic trigonometric equations.
And the first question that we're given is to solve the equation sine squared x minus sine x equals 2 from 0 to 2 pi. So you can solve it as is, or we could make things easier on ourselves by using substitution here. So if I let u equals sine of x, then I can replace this sine squared x as u squared, replace the sine x as minus u, and then equals 2. And then I can get everything together on one side because this is a quadratic equation, and then I would factor. Right? That's one option that I have for solving quadratic equations. So I would have a minus 2 and a plus 1. So here, this means that u would either equal 2 or u would equal negative 1. Now, you don't have to do this substitution here. I like to do it just because it makes things a little bit simpler for me. But once I've done that, I need to substitute the sine of x back in for u right here. So I would say sine of x is equal to 2. And I would also say that sine of x is equal to negative 1. Now, just a reminder, our unit circle has a radius of 1. So right here, sine right here is 0 because that's the y value. The largest possible y value I'm ever going to reach is 1. We also know that when I draw y equals sine of x, it starts on the axis, goes up to 1, goes down to negative 1. So the highest, again, I will ever reach is 1, and the lowest I will ever reach is negative 1. My range has to be from negative 1 to 1 for sine and for cosine. But here we've got sine of x equals 2, which is impossible. This is not within the range of what sine of x is. So sine will never be bigger than 1. So that means that I don't even bother with this equation right here. Sine of x will never equal 2. So now, where will sine of x equal negative 1? I know based on my unit circle that sine of x is negative 1 down here, which is at 3 pi over 2, which means that x would have to be 3 pi over 2, and that is my only solution. Let's check this with Desmos. So here I'm going to type in y equals, and then I'm going to do sine squared x minus sine of x. And remember, I want this from 0 to 2 pi. So this right here is what we're looking for. And then I'm going to do the other side of my equation, which is 2. So I'm just going to say y equals 2. And again, from 0 to 2 pi, I don't really have to indicate that. And if you notice here, my only answer is 3 pi over 2. So just a reminder, I just did y equals this on one side and then y equals this on the other side, and then I just looked for where they would intersect. So my only solution is 3 pi over 2 for this question, okay? Okay, so for this next one that we have here, I'm going to do something very similar, except this time I'm going to let u be cosine of x. So every time I see a cosine, I'm going to replace it with a u. So this is just going to say 2u squared minus 3u plus 1 equals 0. So this right here is u squared, this is 3u, and then we just have the plus 1. Then I'm going to factor this right here. So I've got 2u and a u. And then the nice thing is I would only use 1 and 1. They both have to be negatives. So this is what I would get right here, which means that u would either be 1/2 or u would be 1. Now I can go back and replace the u with cosine x. So I can say cosine x equals 1/2 or cosine x equals 1. And then here it's from 0 to 2 pi again. Let's do the 1 first because that's nice and easy right here. Cosine will only be 1 right here at 0, but it would also be 1 if I go all the way around. It would also be 1 at 2 pi because remember again, this coordinate right here is 1, 0. So this means that x could be 0 and x could also be 2 pi. Now, for cosine of x equals 1/2, that would occur either at this angle right here, which has a coordinate of root 3 over 2 1/2, or at this angle right here, which has a coordinate of 1/2 root 3 over 2. Remember, cosine is x, so I'm going to be using this right here. So that means right here, what I would do first is I would say cosine of beta is 1/2, which means my related acute angle would be pi over 3. But cosine is positive in quadrants 1 as well as quadrant 4. So this would be pi over 3 right here is my related acute angle right here, and pi over 3 right here, which means that x would have to be pi over 3. That's one option. But my second option would have to be 2 pi minus pi over 3, which is 5 pi over 3. So these right here would be my 4 answers. And then if I were to write this in numerical order, I would have 0. This is my first value, my second value, my third value, just going from least to greatest, and then this would be my fourth value. All right, our last example involves secant and cosecant right here. And because we're talking about secant and cosecant, we've got things in the denominators. So that means we have to first of all talk about our restrictions. So remember, secant of x is 1 over cosine of x. So our first restriction is that cosine of x cannot be 0. I can't have 0 in the denominator here. Where is cosine of x equal to 0? At pi over 2 and at 3 pi over 2. So x is not allowed to be pi over 2 or 3 pi over 2. However, right here, theta, and I'm sorry, this is a typo. This should say x. So right here, if we're talking about from negative 2 pi to 2 pi, then if I were to go backwards, then this would be at negative pi over 2, and this would be at negative 3 pi over 2. It's the same thing, but we're just going backwards. So x cannot be any of these 4 angles between negative 2 pi and 2 pi. Okay? So here's my restriction, number 1. I also have cosecant of x, and cosecant of x is 1 over sine of x. So sine of x also cannot be equal to 0, which means that x cannot be equal to, where is sine of x equal to 0? At 0, at pi, and then again at 2 pi. But if I go backwards, it's also not possible at 0, at negative pi, and at negative 2 pi. So none of these answers are possible. Okay, cool. So this is restriction number 2. All right, so let's go ahead and copy this problem down and actually look at what we need to do for this. So I know that secant of x times the cosecant of x is equal to 2 times the cosecant of x. I'm going to get everything together on one side. So I get secant of x, cosecant of x, minus 2 cosecant of x is equal to 0. Okay, and then I'm going to factor. So I'm going to factor out this cosecant of x because it's in common with both of these terms here. When I factor it out of my first term, I've got secant of x. When I factor it out of the second term, I get minus 2. So then what this means right here is that either cosecant of x equals 0 or secant of x minus 2 equals 0. I'm just setting each part equal to 0. Well, cosecant of x can never be 0 because what this means is that if cosecant of x is 0, that means that sine of x is the reciprocal of 0 or 1 over 0, which is impossible. So this will give us no solution here. This is just not possible here. On the other side, I would move the 2 over and I get secant of x equals 2. And we might think, well, this isn't possible either because my number needs to be between negative 1 and 1. But that's only true for sine and cosine. For secant, I need to convert it into cosine of x. And because these are reciprocals of each other, I'm going to take the reciprocal of 2, which is 1/2. So here, a possible answer for cosine of x could be 1/2. So what we would need to do is take a look at our unit circle and find out what beta value would give us 1/2. And we know that the beta value that would give us cosine is as 1/2 is at pi over 3. So that means that beta is pi over 3. And because this is positive, that means that we're looking at values in quadrants 1 and 4. So right here in quadrant 1, one possible answer is pi over 3. The other answer in quadrant 4 is pi over 3. So actually, let me write this down. That one answer for x would be pi over 3. Another possible answer for x would be 2 pi minus pi over 3, which is 5 pi over 3. So here's one answer, here's another answer. However, reminder, theta or x here can be anything between negative 2 pi to positive 2 pi. So if I were to work the other way around right here, here's 0. When I work backwards, this would be negative pi over 3. So another possible answer, so we'll just circle this right here. Another possible answer for x could be negative pi over 3. And then the other answer would be still in quadrant 1. However, this is at negative 2 pi. So it's pi over 3 short of that value. So my last answer for x would be 2 pi minus pi over 3, but it would be the negative version of that answer. So x4 would be negative 5 pi over 3. So my full solution for this in numerical order from least to greatest would be negative 5 pi over 3, negative pi over 3, positive pi over 3, and then 5 pi over 3. Let's check. I'm going to put y equals secant x times cosecant of x in my first line. And then in my second line, I'm going to do 2 cosecant of x. So here I'm going to type in secant of x times the cosecant of x. But this is from negative 2 pi to positive 2 pi. Okay, so this is what the left side of my equation looks like. Now for the right side of my equation, I'm just going to type in 2 cosecant of x. And again, I'm going to make sure that I have that restriction here as well. And I can see that one solution is at negative 5 pi over 3. My next solution is at negative pi over 3, just looking to see where the green and the blue intersect. Our next solution is at pi over 3, and our last solution is at 5 pi over 3. So I know I did this right, and I'm good to go. And that's it for this video. Let me know if you have any questions, and otherwise I'll see you in class. Bye.